Hey guys, so this is the first mind capture I'm going to do, and it's going to be testing the grape's density and how it is when you put it with soda. So pretty much what I'm doing right now is I'm pouring my soda in very slowly so that I can get all that CO2 bubbles to pop and have less of them, which will make the project go smooth. And yeah, so the stuff that you're going to need is of course 7-Up, 2 grapes, 1 peeled, 1 unpeeled, and a clear drinking glass to see what happens. So right now I'm just waiting for the soda to kind of be flat. I want it to kind of be in the middle where it's not too bubbly but not like completely flat to where the project won't work. Yeah, so right now we have the peeled grape, the unpeeled grape, and the question here would be which grape would sink and why? And so I'm going to be demonstrating this by first putting down the unpeeled grape, and as you can see it sinks immediately to the bottom, which is because it doesn't have enough bubbles on it right now. And so just give it some time and it will slowly rise up, because as the bubbles go onto the skin it will go up. And so the unpeeled grape floats, and the reason why this happens is because the unpeeled grape has a water repelling property called a hydrophobe that causes the CO2 bubbles from the 7-Up to adhere to the grape skin, and this makes it become lighter in weight and float to the top. And this is in contrast to the peeled grape, which lacks hydrophobe skin, and without this hydrophobe skin it becomes a hydrofuel, and a hydrofuel is water attracting compared to the hydrophobe, which is water resisting. And so this kind of shows you the difference between adhesive and cohesive forces, and is a pretty good demonstration. So also what happens soon is as the soda gets more and more flat, the bubbles start to lose its, the bubbles just start to pop. And so as the grape skin loses all these bubbles, it starts to slowly sink to the bottom. And the reason why this happens is because there's no more bubbles to support it, and it becomes less and less adhesive and more cohesive. So as the soda becomes more and more flat, it starts to sink to the bottom, but then there would still be bubbles in the bottom, and it starts to pick up those bubbles and float to the top. And it will continue to repeat this process until until the soda is completely flat. So what's going to happen now is I'm going to be showing you guys the video of what happens 20 minutes later when the soda starts to become flatter and the grape starts to become less adhesive, more cohesive, because most of the CO2 bubbles are going to be leaving. So that is going to be next. Hey guys, so this is going to be my second mind capture, and I'm going to be doing it on sinking the pepper, and it's going to be testing whether or not that pepper has a higher or lower density than water, if pepper in fine ground state can float in water, and if you can change the density in pepper by grinding it. And also, what does the detergent do to the water surface? So pretty much what's going to happen right now is I have two types of pepper. I have grounded pepper and a whole pepper. I have some water and some liquid detergent over there in a little cup. And so as you can see, one of the peppers sinks to the bottom, and I point it out with my finger, and geez, my finger looks kind of fat, but whatever. So as you can see, 2 of the peppers didn't really make it, but the fact is that you can show 1 making it, and it usually just the air bubbles usually trap the pepper and it moves to the side. It's kind of crazy. It's kind of a hard experiment to do, but the fact that I got 1 pepper shows you that it's the density. And now you're going to see how the grounded pepper has an effect on the water's surface. So what I do is I'm about to pour in the pepper, and I pour the pepper in, and you can see the pepper you never really see any pepper flakes inside under, like, breaking the water surface. They're kind of all just floating there, just as you can see over there with the 2 failed whole pepper attempts. But yeah, so the reason why this happens is because the pepper is so light that it doesn't break the surface tension of the water, and therefore it doesn't even break the surface tension, so therefore it's still on top and doesn't really sink. And so the water molecules and their cohesive forces form a film which can hold up the relatively light objects like needles and, just light objects. So now what I'm going to be doing is I'm going to be using liquid detergent and showing you what it does to the water molecules. And so I'm going to be pouring it in right now. And as you can see, as an immediate effect, the water molecules start to, break the cohesive attraction forces between the water molecules, and the weakening surface tension of the water causes the film to be removed, and this causes the pepper to start to sink. And so I can show you that the pepper starts to sink around. It's kind of hard to see. I'll be showing you a second video of how it is, but as you can see, the pepper starts to sink. And so the question is, what forces were weakened between the water molecules when the detergent was added? So like I said, it was the cohesive force attraction that was weakened, and so the water molecules start to lose that film, and therefore they start to sink. And so for the last video, I'm going to be showing you how the pepper flakes sink, or a clear version of the pepper flakes sinking with the help of the liquid detergent. And this is probably going to be the last time I talk, so I guess I'll see you guys later.